StackQL is a multi-cloud and SaaS asset management and automation framework which uses a familiar analyst-friendly SQL language and implements a simple intuitive object model. StackQL allows you to perform live queries against a provider to bring back asset and configuration data in real time. StackQL gives users visibility across their entire cloud and SaaS estate. It can be used for asset management, cloud security posture management, FinOps, automation, and much more. StackQL's object hierarchy, which consists of provider, service, resource, method, provides an easy mental model for developers and analysts to work with multi-cloud and SaaS resources. StackQL's no-code provider interface contribution framework makes the product infinitely extensible across multiple cloud and SaaS providers. StackQL allows you to discover information about a provider, such as the available services, resources, and methods available in the provider. So if we show an example here, I can see that I've got a Google provider installed. I can start to list the different services that are available in that Google provider, such as, in this case, I'm going to filter it down to the Compute Engine API. I can further go through the resource hierarchy and see that there is a resource called Google Compute Instances, which I can start to look at the different attributes that is the available fields for that particular resource, as well as show the methods available to interact with that resource. And these could include your standard CRUD methods, such as select, insert, delete, as well as your lifecycle methods, such as start, stop, attach disk, detach disk, and so forth. So the real power of StackQL is its ability to query cloud and SaaS providers in real time and bring back asset and configuration information. So I look here and I've got a very simple select statement where I'm going to bring back all of the Compute Engine instances in a particular project in a particular zone and the status that they're in, which I can also do something like this where I can perform an aggregate query and show the different instances I've got grouped by their status. In this case, they're all running. So I can perform these type of queries against a live provider backend. I can bring back the data interactively, as I've shown here in our shell application. I can also do this programmatically with outputs to JSON and CSV output formats. As StackQL is a data-centric solution, it gives users the ability to analyze information coming back from providers. So in this case, I'm going to do some simple examples using an Okta org, using the Okta provider. So in this case, I'm going to run a query and I'm going to list the different users in an org and their statuses. And this will bring back a grid result set. Again, this is a live query against a Okta provider. And I can see I've got various different users and various different statuses. Furthermore, I can start to look at this in a visual format. So I'm going to take this and I'm going to generate a histogram where I'm going to look at the various different users and the numbers of users in the different statuses within my Okta org. In addition to the ability to query cloud and SaaS providers and bring back information, StackQL can also perform provisioning and deprovisioning operations. So in this example, I'm going to create multiple Compute Engine instances using an insert statement within StackQL. So this is standard SQL grammar. Conversely, I can terminate instances using a delete statement. The other thing we can do is we are capable of creating what are called infrastructure templates, which are blank templates created from the API documentation, which allow users to deploy new resources and list the different fields available. So another unique feature of StackQL is not only can we provide provisioning, deprovisioning, and query functions, we can also allow you to perform lifecycle methods such as starting instances, stopping instances, attaching disks, detaching disks, attaching NICs, detaching NICs, and so forth. So in this case, we are going to run a command to stop a Compute Engine instance. So this is done asynchronously, that is non-blocking. So if I was to run my select method again, I should see that I've got 2 instances in running state and 1 instance in the stopping state. Again, this is a live query. We can also run commands in blocking mode, that is synchronous mode, where we wait for the operation to complete and we give status in progress. So in this case, we're going to perform a blocking stop operation. So this won't return back until the instance is actually in a known stopped state. So these are different lifecycle methods and ways you can interact with infrastructure. It's probably a little bit more IaaS-centric, but in this case, we can see that if I was to run this select again, I've got 2 instances in terminated, effectively stopped state, and 1 instance in a running state. So these are lifecycle methods. So thanks for your time. You've seen the various capabilities of the StackQL solution. We'll be actively adding new features and extensions to the product, so please stay tuned. Thanks.